Hi there, Wildcats. Welcome to your geometry class. In today's lesson, we'll be doing kites and trapezoid. And our objective is we have to use triangles because we have already been talking about triangles for so long now. We'll be using triangles, triangle congruence to understand kites and trapezoids. And the vocabulary that we'll be using in here is mid-segment, meaning it's the middle segment in a trapezoid, and the mid-segment of a trapezoid, meaning it's the middle segment of trapezoid. So we'll just proceed on. First is the kite. Okay, so what are the characteristics and what is special to kites? Okay, so this is I'm going to put here. Sorry, there you go. Theorem 6-3. Theorem 6-3. It states that the diagonals, okay, the diagonals of a kite are perpendiculars. Okay, so if I'm going to draw a diagonals of a kite, so let's see if I have here. Maybe I'll just do a straight line, and this will be a segment. So from D, okay, if I'm going to connect that with B, so vertex D, okay, to vertex D to vertex B, and I'm also going to connect from vertex A to C. Okay, these are the diagonals of the kite. Okay, and it says that based on the theorem 6-3 that the diagonals of a kite form a 90 degrees, or they are perpendicular to each other, meaning these are 90 degrees here. Everything is 90 degrees. Okay, and also that there are two pairs of congruent sides. When I put the diagonals in there, it will give me that this AB here is congruent to CB. DC is congruent to AD. All right. I can now say that you have your AB, segment AB is congruent to segment CB, and also we have segment DA is congruent to segment DC. Thus, in your theorem 6-3, it says that the diagonals of your kite are perpendicular. We can now say that segment DB, this one, is perpendicular to segment AC. Okay, so that is the main purpose now of the kite that we have there. I'll repeat. A kite has two pairs of congruent adjacent sides. Okay, and of course the diagonals are perpendicular to each other. So that's the general characteristics of a kite, and we'll be using that to solve problems involving kites. Let's see. Theorem 6-3 is what I have told you. Okay, so the diagonals of the kite are perpendicular. Okay, it's this one. So if they are perpendicular, then they form a 90 degrees. So this is a big picture of it. It's more maybe it's a little clearer to understand. And we'll be using 6-3, theorem 6-3 to solve problems involving kites. Okay. Now, quadrilateral, which is quadrilateral PQRS, is a kite. Okay, it's given already with diagonals QS and PR. All right, and even if it's already given and it's automatically that this the two pairs of sides are already congruent. So you have QR is congruent to PQ and RS is congruent to PS, and it says there that the diagonals are QS and your PR. Thus, if these two diagonals, okay, these two diagonals, they form, these two diagonals are perpendicular. Thus, the intersection, they will form a 90-degree angle. Okay, and considering that our problem here is states that it's a kite, the quadrilateral is a kite. Therefore, to answer your question A, what is the measurement of angle 1? Identify where is angle 1. Angle 1 is here. And we already identified that this quadrilateral is a kite. And we have QS and PR are the diagonals. Therefore, the measurement of angle 1, it's automatically 90 degrees. Why, Mr. Kino? It's based on theorem 6-3. It states that the diagonals of a kite are perpendicular, meaning they form a 90-degree angle at their intersection. And the angle 1 is one of the angle in the intersection of these two segments. So angle 1 is considered to be a 90 degrees. Okay. Next is what is the measurement of angle 2? So where is angle 2? It's here. The measurement of angle 2, it's this one. Okay, given there is a measurement of this angle is 35. Okay, again, we are applying triangle angle sum. So if I'm going to recapture this one and redraw, it's like this. Okay, so angle 2 is here. So angle 2 is here. And we have the measurement of this angle, which is 35 degrees. Okay, I'll just write it too small. So this is 35 degrees, and this one is unknown. However, okay, because this is a perpendicular lines, okay, automatically all of those, okay, missing measurements in there is also 90 degrees. Therefore, this is also 90 degrees. So we have 90 degrees and 35, and the missing angle is angle 2. And we know that triangle angle sum states that the sum of the angle of a triangle is equal to 180 degrees. So I'm going to add the measurement of angle 2 plus 90 plus 35 is equal to 180 degrees. Okay, therefore, the measurement of angle 2 plus, so that's 9, 10, 11, 12, that's 125, is equal to 180. Now I am going to subtract 125 both sides, 125. And my final answer here is that the measurement of angle 2 is equal now to 55 degrees. As easy as that. Again, we are using our different theorems that we already discussed. So maximize using them. All right. Next is angle 3. Okay. So your angle 3 is here. So angle 3 is there. So I'm going to erase that. Now, if you are going to analyze, and I'm going to redraw, okay, I'm going to redraw here my triangle. I can see it here. So this is P here. So I'll just put P. And then R is here, which is angle 3 is also here. So angle 3. And then angle Q is here. And these two sides, PQ and RQ, are congruent. So they are congruent. And angle P here, which is 35 degrees. And we don't have any measurement here. It's not 55, okay? So analyzing this, we can consider that this two leg here, okay, the two leg, which is we said that based on the given, PQ is congruent to RQ. Okay, so PQ is congruent to RQ. Then we can consider this one as an isosceles. So this given triangle is an isosceles. Sorry about that. So isosceles triangle. Okay. So by definition of an isosceles triangle, we said that if the two legs are congruent here, they are considered to be yeah, two congruent legs for an isosceles triangle, and the base angle are also congruent. In your isosceles triangle, it always that your base angle are congruent. So if the measurement of angle P here is 35, then the measurement of angle 3 is also 35. So I can now conclude that the measurement of angle 3 is equal to 35 degrees. And my justification here is that the triangle given is an isosceles triangle, and in an isosceles triangle, the base angle are always congruent. Okay, so this is a skills of analyzing the given and applying the theorems that we already discussed before, and we are adding it. We're still adding theorems that we can still use. Okay, it's like from a general topic we are making it to a specific topic. Okay, we are chopping it to pieces. All right, next example. Next theorem. Sorry, not example. Next theorem, we have 6-4 and 6-5. Your 6-4 and 6-5, it talks about isosceles trapezoid. Okay. Again, the word when we say isosceles trapezoid, so this the main characteristics is that the two legs are, they are congruent. So in 6-4, in an isosceles trapezoid, each pair of the base angle are congruent. So if we have this illustration, okay, of course BC and AD. So this arrow here, it symbolizes that these two segments are parallel, meaning they will not intersect at each other. And AB is congruent to DC. Okay, this small thing here symbolizes congruency. Now, if this is an isosceles trapezoid, then the base angle, okay, are congruent. So your BAD, which is in this angle, is congruent to CDA, that is congruent. Now, if I'm going to rotate, okay, if I'm going to rotate 180 degrees, okay, your BC will become the base angle. So I could say that your angle B is congruent also to angle C, which is ABC. ABC is congruent to AD or DCB. Okay, so those are that is the theorem 6-4. Okay, that every the base angle in your isosceles trapezoid are congruent. Now, in this example, the base angle is AD. Now, if I'm going to rotate that 180 degrees, your BC will become the base angle. Okay. Next, theorem 6-5. The diagonals of an isosceles. Okay, take note. The diagonals of an isosceles trapezoid. Okay, so you have to consider that an isosceles trapezoid has, of course, a pair of parallel bases, and then a pair of congruent legs. Okay, so in here, if we have this trapezoid, okay, then AC is congruent to BD. So their diagonals are always congruent. Okay, so that is theorem 6-4 and 6-5, and we'll be using these theorems to solve problems. Let's take a look at this example that we have here. All horizontal beams of the high voltage transmission tower are parallel. Okay, the word there is parallel, and to the ground. So this is the ground here. So that means that this one is parallel to an arrow. That's an arrow parallel here, parallel to that, and parallel here. Okay. The top section is an isosceles trapezoid. The center section is an isosceles trapezoid also. So this one is isosceles, and this one is also isosceles. Why? Because they have 10 feet, 10 feet, 14 feet, and 14 feet. So our problem now is we have to, the given is that angle 1, this angle here, is equivalent to 138. Now the problem is, what is the measurement of angle 2? All right. Now we'll be using the theorems that we discussed before. So the sum of the interior angle of a quadrilateral. Okay, we are talking now about quadrilateral. It's 360, right? So I'm going to add the measurement of angle 1 plus the measurement of another angle 1 here, measurement of angle 2 and the measurement of angle 2. It's equivalent to 360. All right, so I'm going to put the measurement of angle 1 plus the measurement of angle 1. So because there are two, this is our congruent, plus the measurement of angle 2 plus the measurement of angle 2, which is 360. This one here. So I have here this and that and this and that. So there you go. So make sure that this angle 2 here, the base angle are congruent, okay? And of course the base angle, when I put that again on your isosceles trapezoid, are also congruent here. That's why I have to double them. So angle 1 is 138. So 138, 138, 138 plus 138, because they are congruent, plus twice the measurement of angle 2, which is equivalent to 360. And we all know that 138 plus 138 is 276. So we have 276 plus twice the measurement of angle 2 is equal to 360. So we have twice the measurement of angle 2 is equal now to 360 minus 276, which is 84. Okay, because I did subtract this one, 276, that will be cancelled, 276. So 360 minus 276, that's 84. And I'm going to divide both sides by 2. Okay, therefore the measurement of angle 2 is equal now to 42. So each angle, the base angle here, is the measurement will be 42. So this angle here and this angle measures 42 degrees. All right. Now, if there is a follow-up question here, so it's the lower part. So look at the follow-up question. It's the lower part here. So we are looking at this one. So I'm going to remove that. Okay, and let's solve question letter B. One cross supporting in the center of the tower measures 4c plus 3. It's a diagonal. And other measures 6 minus 5. What is the length of each cross support? So if you go back on Theorem 6-5, it states that the diagonal of isosceles trapezoid are congruent, meaning they have the same measurement. They are equal. So what I'm going to do is that this measurement here, 4C plus 3 and 6C minus 5, they are equal, they are congruent. So I can set up an equation looks like this. 4C plus 3 is equal to 6C minus 5. And then I'm going to isolate my variable C. So I'm going to subtract, okay, I'm going to subtract 6C both sides. All right, so this will give me negative 2C plus 3 is equal to negative 5. And then from here, I'm going to subtract 3 both sides. Okay, this will be canceled. Of course, I have negative 2C is equal to negative 8, right? Therefore, I'm going to divide both sides by negative 2. Thus, our answer here, the value of C is positive 4. Okay, C is positive 4. Now we're ready to the length of each cross support. Okay, so the length here would be just plugging in the value of C that we get. So that's 4C plus 3, which is 4 times let's open parenthesis. Sorry about that. So the value of C is 4 and then plus 3. So 4 times 4 is 16 plus 3. Therefore, this support here will be 19 square unit, 19 unit. Now, on this part is we have 6C minus 5. So 6 times 4 minus 5, which is, again, it's 19. Because they are congruent. So that is how you use your theorems in solving given problem. All right. Next, on this problem, we will be using your trapezoid mid-segment theorem. Okay, when we say mid-segment, so let's say I have here a trapezoid. Your mid-segment, it's the segment in between. And how would you do that? So let's say the base, two bases is A and B. To get your mid segment, so you have to add, okay, 1/2 of the sum of the two bases. Okay, we know that. You add your A and B and then get the half of it. So that is your mid segment theorem. Now in here, what are we going to do is how much trim does she needs for the 3 handbags? So we have to explain that. So step 1 is find the value of X. Okay. All right. So Paxton makes a trapezoidal handbags for her friend. She stitches decorative trims along the top, middle, and the bottom. It's this one. Okay, which they have 2-inch in between, and the problem is how much trim does she need for the 3 handbags. So we are looking at the trims that we have here. All right, so first is we have to find because we have the measurement of the top portion, which is 6 inches. Okay, and then the bottom portion, which is 9 inches, and we have to get the mid segment here. So to find that mid segment here, we have 1/2, okay, 1/2 6 plus, let's say this is your A and that's your B, plus 9, which will give us 1/2 of 15, which is 1/2 of 15 is 7.5. So we know that the mid segment, so this is now your mid segment here. Your mid segment is at 7.5. Second step is we have to find the amount of trim that she needs. First is find the amount on one side. Okay, so one side. So you just add them together. So 6 plus 9. One side is 6 plus 9 plus the mid segment, which is 7.5. which will give us, that's 15 plus 7, that's 22.5. Okay, then you have to multiply by 2 for the sum of the sides per handbag and by 3 for the number of bags. So what I'm going to do is, because this is just only the first amount, this is the first part, okay? So this is one side, 22.5, and on an handbag, there are two sides there. So what I'm going to do is, the trim is 22.5 for the first side. I'm going to multiply that by 2 because there are two two faces there. So the front and then the back portion. So there are two. And then it says there that she's doing a 3 handbag, so I'm going to multiply that by 3. Okay. So multiply them together, it will give you 135. Now the interpretation now here is that Paxton needs 135 inches. Okay, 135. So we have Paxton needs 135 inches. 135 inches of trim. Okay, so that is how we use your trapezoid mid-segment theorem. Your trapezoid mid-segment theorem is that if you are looking at the middle segment on a given trapezoid, okay, so you add the measurement of the two bases and then you divide that by 2 or multiply it by 1. Right. Now, what I want you to do now in our discussion is that I want you to look at this this work. Reagan has an error here. Now, what I want you to do is I want you to explain the error committed by Reagan. All right. So make sure that you have to explain it well on the discussion part in your below this video. Thank you guys, and we'll see you next time. Bye bye.